Next video, a word problem. A city commission has proposed two tax bills. The first bill requires that a homeowner pay $1,800 plus 3% of the assessed home value in taxes. The second bill requires taxes of $200 plus 8% of the assessed home value. What range of home assessment would make the first bill a better deal? Okay, let's figure out what the two bills are first. Now, when I read it, it says the first bill requires that the homeowner pay $1,800 plus 3% of the assessed value. The second bill says $200 plus 8% of the assessed value. So everything depends on that assessed value. So let's let X equal the assessed home value. So Bill 1 says it's $1,800 plus 3% of the assessed value. So Bill 1 would be 1,800 plus 0.03x. The second bill says it's 200 plus 8% of the assessed value. So the second bill would be 200 plus 0.08x. Then the question they ask us is what price range of home assessment would make the first bill a better deal? First bill, a better deal. Okay, we got to try to figure out what that means. Now, it is assumed by better deal, they mean a better deal for the homeowner, not for the city or state. A better deal for the homeowner. And so what they mean by that is that the first bill, it says, the first bill would be less than the second bill. That's what we mean by a better deal from the homeowner standpoint, that he or she is paying less. That's what we mean by better deal, that you're paying less. So in this case, that's 1,800 plus 0.03x less than 200 plus 0.08x. And now we just solve that. Let's get those x's together. And so I get 1,800 minus 0.05x is less than 200. Subtract that 1,800 from both sides. And what, that's negative 1,600. Divide both sides by that negative 0.05. But when I divide by that negative 0.05, I reverse that inequality. Got reversed. Divided by a negative. And so we come up with x greater than, and the calculator tells me that 1,600 divided by 0.05 is 32,000. So as long as your home is greater than $32,000, is worth more than $32,000, tax bill number 1 would be the way to go. And an interval notation, if that's what they want, 32,002. infinity. Okay, so these guys are all what we call simple inequalities. Moving on a little bit to compound inequalities. And depending on how good your algebra background was in the past, you may have studied two different types of compound inequalities with an and, compound inequalities with an or. We're just going to do the ands. So right there, there's a compound inequality. 7 is less than or equal to x is less than or equal to 12 is an example of a compound inequality. And it is the same as this statement here, that x is greater than or equal to 7 and x is less than or equal to 12. That those two things mean the same thing. It's just that when there's an and in between them, we're able to write it as one inequality. And so it's just really saying this range of numbers between 7 and 12. In mathematics, the word and means the intersection of two sets, or that's the set of numbers that satisfies both conditions. We're not going to harp on that too much, so we'll even cover it up. 7 less than or x less than 12 is in standard form, meaning the smaller number is on the left, the variable is isolated in the middle, and the larger number is right. A compound inequality of the type that we're going to be solving, a compound inequality is solved when it is in standard form. Now the way I like to do it, now many algebra teachers split it apart into two inequalities and then put it back together. And when I see that, almost invariably people get it wrong. We're going to leave it all together. We're going to leave it as one unit. We're not going to split it up. So this compound inequality may be viewed as having three parts, a left, middle, and right. To solve a compound inequality, look at only the middle and right parts, view those parts as you would an ordinary linear inequality, and decide what operation to perform. Once you've decided what operation to do, perform that operation on all three parts, left, middle, and right. Keep deciding what operation to do and performing the operation to all three parts until you achieve standard form. So, what the hell does she mean by that? Let's go through it. Okay, solve this guy, which means I want to get the x alone in the middle. Now, I'm just going to write this bigger so we can all see it a little bit more. What I suggest students do is this. Cover up part of it. I always cover up the left. Cover up the left and then decide what you would do with that inequality. As I look at it, it has a fraction. I'm going to clear my fractions. So again, I looked at just part of it. I decided, oh gee, I should clear my fractions. I clear the fractions in this case by multiplying everybody by 5, and then I multiply everybody by 5. Left, middle, and right. And so then I come up with negative 30 less than or equal to 2x minus 15 less than 20. And then I just keep doing that same process. Cover up the left. Decide what you would do. If I was looking at that, I'd say, well, gee, I should add 15. So I'm going to add 15. But I add 15 to the left, middle, and right. That I cover up part of it to decide what to do. Then once I decide what to do, I do it at all three parts. And so that's negative 15 less than or equal to 2x less than 35. Keep doing it. Cover up the left. If I was looking at that, I would decide to divide by 2. So, divide by 2. Just divide all three parts by 2. And then there's not much we can do here. That is just negative 15 halves. Please do not tell me it's negative 7.5. Less than or equal to x less than 35 halves. Do not tell me that would be 16 or 17.5, I don't want to know it's 17.5, and I certainly do not want to know that it's 17 1/2. Just leave it like that. Then interval notation, -15 halves to 35 halves. Square bracket on the -15 halves because it had an or equal to. Parenthesis on the 35 halves because it did not have the or equal to. And if you needed a graph, there's -15 halves, there's 35 halves. Square bracket on the -15 halves. Parenthesis on the 35 halves. And we have solved that. Okay, let's do another one. Solve each of the following. Okay, pretty much the same idea. Cover up the left. There. Cover up the left, decide what to do. So if I'm looking at that, I'm going to subtract 5 from everybody. So I'm just copying it down again. Subtract 5 from everybody. And so that's going to give me -1 is less than -2x is less than or equal to 4. Again, cover up the left, decide what to do. I would divide by -2x. So let's divide by -2x. Or -2, excuse me. And divide everybody by -2. But I just divided by a negative. So I reverse the inequalities. Those guys got reversed. Divided by a negative. And so that gives me 1/2 greater than x greater than or equal to -2. That is a true statement, but it's not standard form. So going up here, for standard form, we need smaller number on the left. And so you can kind of just envision picking the whole thing up and flipping it around. And so this is going to be -2 less than or equal to x less than 1/2. As long as the inequalities are still pointing at the same item. So between the x and the -2, it's pointing at the -2. Still pointing at the -2. Between the 1/2 and the x, it's pointing at the x. Between the 1/2 and the x, it's still pointing at the x. Now that is in standard form. The smaller number is on the left. Then the interval would be -2 with a square bracket to 1/2 with a parenthesis, and there would be the interval. But we still did have to reverse the inequality because we divided by a negative. But then to get that standard form, I had to kind of flip the whole thing so that the smaller number would be on the left, and then just making sure that the inequality symbols still point at the same thing. Between the x and the -2, it needs to point at the -2. It's pointing at the -2. Between the x and the 1/2 and the x, it has to be pointing at the x. Between the x and the 1/2, it's pointing at the x, which then gives us our final answer. And that's where we will end this video.